Welcome to Unit 4, Lesson 3, exponents that are unit fractions. Let's explore exponents like 1/2 and 1/3. Here are our exponent laws. Please take a look at them. We're going to use this through most of this unit. Okay, let's look at our first example. Sometimes it's squared, sometimes it's cubed. Okay, find a solution. To get rid of a term squared, we have to take the square root of both sides. When you take the square root of x squared, x pops out. And the square root of a positive number leaves +5 and -5. Z squared equals 7. We take the square root to get rid of the square. And z equals plus root 7 and minus root 7. Now, for the next one, y cubed is 8. We have to take the cube root to get rid of a cube, not the square root, so be careful. To get rid of a cube, you need to take the cube root. Whatever root you take a variable to get it to solve an equation, it must be equal to the power that it's raised to. So the cube root of y cubed is y, and the cube root of 8 equals 2. Take the cube root of w. W equals the cube root of 19, and that's your answer. Okay, let's look at this problem right here. Now, what I forgot to mention at the beginning is that a unit fraction, what is a unit fraction? A unit fraction has a numerator of 1, and we don't know what the denominator is. So, in a unit fraction, the numerator is 1. So now let's look at this problem. Claire said that I know that 9 squared equals 9 times 1, and 9 to the first power equals 9, and 9 to the 0 equals 1. I wonder what 9 to the 1/2 means. Well, I am not going to graph this. What I'm going to tell you is that 9 to the 1/2, 1 is the exponent, and 2 is the root. So what 9 to the 1/2 means is the square root of 9 to the first power. But mathematicians are lazy. They don't like writing 1 for an exponent, and they don't like writing 2 because they understand, it's understood or assumed that the square root is the square root. There's no such thing as the first root, and anything above the square root, you have to indicate the root in the space provided. So what you'll see on most problems is this, and that's all you will see. Okay, I'm not going to worry about the graphing part right now. What I am going to worry about is B. So 9 to the 1/2 times 9 to the 1/2. All right, so when we multiply the same base, add the exponents, 1/2 plus 1/2 equals 2/2, which equals 9 to the 1, which equals 9. So, for that to be true, what must the value of 9 to the 1/2 be? So the square root of 9 must be 3 because 3 times 3 equals 9. Any number written is automatically assumed to be to the first power. So if I had to write it like that, that might be a better explanation. Okay, Diego saw Clark's work and said, now I'm wondering about 3 to the 1/2. So 3 to the 1/2 is the square root of 3. I'm not going to graph it. Now, with this one, it's a little different. 3 to the 1/2 squared. When you square 1/2, you multiply the exponents, which becomes 3 to the 1/2 times 2 over 1, which is 3 to the 2 over 2, which is 3 to the 1. Okay, these are unit fractions. The numerator is the exponent. The denominator is the root. So 25 to the 1/2 is same thing as writing the square root of 25, which is plus or minus 5. When you see the plus minus together, that means plus or minus. 15 to the 1/2 equals the square root of 15. This is an exact number. When you take the square root of a non-perfect number, the result is an irrational number. And you have to round irrational numbers because they never end and they never repeat. To get rid of 8 to the 1/3, that's the cube root of 8, which is 2. Odd roots have 1 answer. Even roots have 2. So this equals the cube root of 2. This is exact because 2 is not a perfect number. It is not on a list of perfect cubes. Okay, we're going to play the matching game. 7 cubed is 343. So 7 cubed goes there. You know what? Let's do this better with highlighting. And that way it might look neater. Okay, so if I pull out my highlighter tool, 7 cubed is 343. 7 squared is 49. 7 to the first is 7. 7 to the 0 is 1. 7 to the negative 1 is 1 over 7 because we know that all whole numbers can be put over 1. And when you raise something to a negative power, you flip the fraction upside down. 7 to the negative 2 is 1 over 7 squared, which is 1 over 49. So let's show you this again. So 7 to the negative 2 equals 1 over 7 squared. When you have a negative exponent, it flips the fraction upside. Once the exponent goes across the fraction bar, it becomes positive. And that's why this is 1 over 49. The same reason 7 to the negative 3 is 1 over 343. 7 to the 1/2 is the square root of 7. 7 to the negative 1/2 is 1 over the square root of 7. 7 to the 1/3 is the cube root of 7. And finally, 7 to the negative 3rd is 1 over the square root of 7. 1 over the cube root of 7, I'm sorry. That's messy. I wrote through the other answer. So hopefully you can follow along with the colors.